Hello, Algebra 1, last video of the year. I hope the videos have helped you. I hope you have a good summer. I hope to end my video making career at this point and see you face to face in the fall, because I would always much rather teach class by seeing people face to face and interacting. I just think it's easier for you, it's easier for me. But we did the best we could with this COVID-19. Hope you enjoy your summer. 30, we're looking to do the point first. 30 is the point 2, 4. So the first thing we would do is plot that point by going right 2 and up 4. Then we have to remember a slope thing from the earlier video. Slope is the change in y over the change in x. So if I throw you a 2/3, the 2 goes up, because that's how the change in y goes, is up or maybe down if it were negative. The change in x always goes right though, never left, always right. So I need to go up 2 and right 3 from this dot. So up 2 more, right 3 more, play a little connect the dots, and on we would go. 31 is using the most famous equation in algebra, which is slope-intercept form, y equals mx plus b. The m, for whatever reason, represents the slope. I'm not sure why they picked an m, but m represents the slope. The b represents a thing called the y-intercept. So for 31, the equation's already y equals, so I helped you out there. The slope is just the 6 that's next to the x. And the intercept, I would prefer, instead of just writing -5, I prefer you write it as an ordered pair, 0, comma, and then insert the -5. 32, we're just going in reverse mode of 31. Write y equals, put the 2 next to x, and tack on the -1 at the end. 33, we can graph using slope-intercept form by taking the +4 as our first look to go up 4. And then with a -2/3, we're going down the 2, but still continuing to go right 3. So from here, down 2, right 3, connect the dots, make a line. 34, parallel means the slopes have to be the same and the intercepts have to be different. This first equation is y equals, so I'm kinder to you. The slope is this number and the y-intercept is the other number. The 6x type equation, there's some work to do opposites to get the y alone. To get rid of adding 6x, 5's side would have to be subtracted with 6x. To get rid of the 2, we would have to divide by 2. This would be a decimal, minus 3x. The number with the x is the slope, and we can see that the slopes are the same. The other numbers are supposed to be different, and they are, so after we do that work, we say yes. 35, we're using a different equation called point-slope form. We need to know this equation and how to work it to do anything on the rest of this page. We're going to go always the letter y minus a y coordinate. And for number 35, the y coordinate I gave you is a 2. We're going to put the slope in this slot, which is a -3. And then we're going to go the letter x minus an x coordinate, which in this case I gave you a 1. To get this in standard form means x and y get to the same side and we're not allowed fractions. So I would distribute this to get -3x plus 3. And then to get the y completely alone, because of this subtract 2, I would have to add 2. And those guys at the end would combine to be a 5. And actually one other thing, this would have to come to the other side. Sorry, x and y need to get to the same side. So to undo a -3x, I'd have to add 3x. So y is good, plus 3x when that comes over to join it, and then the 5 is on the other side. 36, same kind of scheme. Y minus, use the 3, slope of 2/5. The minus -1, minus minus makes a plus there for the 1. And then we're trying to be in standard form, which means fractions aren't allowed. So we're going to have to multiply by 5 to cancel that, use that as our LCM. So 5 cancels this, but 5 also has to multiply this side. So 5y minus 15. The 2 wants to distribute to get 2x plus 2. And then standard form means x and y go to a side. So 5y is good. To get rid of a positive 2x, we'd subtract 2x. And to get rid of this minus 15, we have to add 15 onto the 2 and get a 17. 37, we're doing a similar thing, but have to work a little harder to get the slope. With the 1, 4, we would go 1 and 4. If I would have preferred to use 2 and 7, I could have had 2 and 7. I just don't want to do that. But we have to figure out the slope. So again, from other video, this is the formula that gets us slopes. Y2 minus y1, that's 7 minus 4. And for the x's subtracting, that would be 2 minus 1. Top is 3, bottom is 1, 3 over 1 is 3. And then this says slope-intercept form, which means we want the y alone. So we would distribute. And to get the y alone, we'd have to add 4. And those are like terms. So we'd get y equals 3x plus 1 once we combine that. 38 is the same style. 38, to do the slope, we would take a negative 1 minus a 3. We would take a 3 minus a negative 1. That top is negative 4, the bottom's positive 4, grand total slope is negative 1. And then I'll just use the first point. The negative 1 would go here as a plus 1, 3 could go there, and then like the previous problem, we would distribute to get negative x minus 1. And to get the y completely alone, get rid of the subtract 3 by add 3, and just combine those two numbers to get a plus 2 at the end of that. 39, we're graphing an x of negative 2, since that's the x-axis, goes left 2. And we stay there. But this time we do a dotted line, because there's no equal sign involved. And then greater, we usually shade above, but this is the one exception to that. There's no getting above a line that's going to go vertical. So in this case, and in this case only, greater means the shade on the right side, just like the number line. Greater numbers are on the right. For 40, we would go down 1 square to make our first dot because of the minus 1. The 3 is a slope, 3 over 1. Again, the top takes us up, the bottom takes you right. So up 3, right 1. I don't see an equals, so I go dotted again, unless I'm going to shade underneath. Then we're into the last chapter that we have been working on, chapter 12, the final farewell here. So 41, this table maybe can help you. I built this table by doing 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. Square root of 25 would turn into 5. If I went as far as 100, 100 is going to turn into 10, but 42's answer is negative because I sneaked a negative on there. 43, keep the plus or minus sign into your answer. The 1 stays a 1, the 4 turns into a 2, so that's a half. 44, just use your calculator and round to the first location, so it's going to get you 2.4 and 2.6 if you round there. 46, you can just punch in 2 divided by 5, write down the decimal. 47, just do 11 divided by 16, write down the decimal. 48, to make a fraction, just put 95 over its place of 100 and reduce it down to 19/20ths. 49, we never did that lesson this year. We're like a day short from being ever doing that lesson. So that's extra credit if you want to do that one. If you want to think back to your 7th grade decimal chart days and rememorize the 11ths, that one happened to be 8/11ths, but you don't have to do that. It's extra credit if you want to do that. For 50, if you multiply a root 4 times a root 3, we're going to come out of that with root 12. And instead of root 12 being our answer forever, we see if any of these numbers can divide into 12. 4 does 3 times. The square root of 4 can turn into 2. and underneath that root, we're just stuck with a 3. 51 square root of 64, we're just making it 8. There's no radical sign in that. When you do these roots, the radical sign disappears. 52, you have to remember that there's an index of 2 for the x to the 7th, and we want to divide the index into the power. 2 goes into 7 3 times, so that amount of x's comes out of the radical sign. Under the radical sign only exists if there's a remainder, and when 2 goes into 7 3 times, there is a remainder, so there's an x left under there. 53, similar concept, but nothing is left under because nothing has a remainder. We get m to the 2 and n to the 5 by dividing 2 into the powers, but nothing left under the radical sign. 54, we're just combining. The 4 plus the 3 makes 7, leave the root 2 alone. 55, we can't immediately combine these because they're unlike. So with 12, we go back to our thought process of, can any of these numbers help us with 12? And we just did that. 12 a moment ago turned into a 2 root 3. This 2 is multiplying. This 2 is also multiplying. So we want to multiply those 2's to have a 4 root 3 on this. And if we now have like terms, 4 minus 4 makes 0. That best answer is just 0. 56, if you multiply, you'd be getting root 16, is not bad. But if you check the chart, 16 can turn into 4. Best answer is 4. For 57, 4 times 3 is a 12. Under the root, 3 times 6 is an 18. And then we need to think if anybody can help us with 18. 9 can. 9 goes into that twice. The 9, the table tells us, can root into a 3. 3 multiplies 12 to make 36, and the 2 is just stuck under there. For 58, the 4 times 4 would make a 16. Root 3 times root 3 is root 9. But root of 9 is normal 3. So we need to take normal old 16 times normal old 3, that's going to be 48. 59 is a distribute problem. Roots can only multiply other roots. So when the root 2 tries to multiply the regular old 6, it's just 6 root 2. But when root 2 multiplies root 2, you could think about root 4 for a second, but root of 4 turns back into 2. At which point you might observe, anytime you have a root times itself, it's that number but without the root sign anymore. Like root 7 times root 7, it's just good old-fashioned 7. That's a pretty good trick. Last problem of the year, we're looking to FOIL. So these multiply to make a 9. These multiply to be a negative 3 times a root 2. You can't multiply normal numbers and rooted numbers, just put them side by side. Here, 4 times 3 is 12 with a root 2 along for the ride. And here I'll use the trick I just talked about. Root 2 times root 2 is just good old-fashioned 2. Times good old-fashioned 4, that's an 8. That would be a minus sign because the signs there were different. And then combine. Positive 9 and negative 8 is a 1. Negative 3 and positive 12 of these roots would make positive 9 of the roots. We subtract there. When you're adding with one of each, it depends on the bigger, and we subtract. And there's our last answer of the year. Hope summer treats you well. See you guys.